Okay, so today I think we will just revisit all the basic trigonometric identities and then use them to solve simple problems. Okay, all NCERT level. Now, one thing that you need to understand is there are many more identities in trigonometry. Okay, which of course can be derived using these basic identities. So you should not become, let's say, too, I mean, you should become happy, but not become too happy, even if you're able to solve all these problems, because these are really simple problems. But in case you're finding them, let's say, difficult, initially, I think it is natural to find them to be difficult. It's quite natural because you are looking at them for the first time. So my advice is, okay, so look at the problem solving session, today's session again. Okay, and then open your textbook, go to the exercise, and solve all those problems. Okay, on your own. Okay, on your own, and then I'm sure you'll feel better. Okay, is it okay? I think you guys will do that.
Yeah, sir.
Yeah. Okay, so let's, again, this is what I will do. I'll show you a problem on the screen. I'll pause for a while. Okay, so maybe 2 or 3 minutes. Once you have given a try, then we will discuss. Okay. Okay, so try this one. Okay, so here they have given that cos x is 3/5 and x lies in the fourth quadrant. Our OX is the reference line. So if you go to some point in the in the fourth quadrant. Okay, so maybe I think I should draw a line and then do that. So if it is in the fourth quadrant, the point goes around the circle and then comes to this position. Let's say, assume that. And if you join the point with the center with a line, so you have that line. Cos x is the x coordinate, right? So cos x is x coordinate. So we'll put that 3/5. And then we need to find the y coordinate, which is sine x. The angle that they are saying, because they're saying x is in fourth quadrant, so this is the angle they're talking about. Okay, so that is the angle, that is x. Okay, so it's more than 270 degrees. But now, how do we get all the other trigonometric ratios? Cos x is 3/5, and because it is in the fourth quadrant, it will be positive, right? So the x coordinate will be positive. So if we drop a perpendicular here, so this value will be positive. But the y coordinate in fourth quadrant will be negative. So we need to get this value. Okay, so this. Now, how do I use this 3/5? Guys, can I say, if I look at this triangle OMP, can I say that OM is proportional to 3? Maybe I'll try to draw it here. If I draw this triangle here, maybe I should draw it a little better. Okay, so this is the right angle, OMP. So can I say OM is proportional to 3 and then OP is proportional to 5? Can I say this? I think that is.
How is it?
Okay, yes, Sarsha.
Sir, how is it 3 and 5 then? I didn't get that.
Okay, see. So when you take, let's say 3/5, I'm saying, see, I'm not saying OM and then OP are 3 and 5. I'm saying they're proportional to. Okay, now why am I saying proportional to? If this is a unit circle, suppose. Okay, let's imagine this is a unit circle. if this is a unit circle. If this is a unit circle, what is the value of OM?
Uh,
OM will be 3 by 5.
yeah, okay.
And then what is the value of OP?
OP would be 3 by 5 square plus 3 by 5 square.
No. This is a unit circle. So unit circle has a radius 1 unit.
Yeah, okay.
So then OP will be 1 unit, right?
Okay.
OP is 1 unit. You understand?
Okay.
We are saying this is a unit circle. So OP will be 1 unit. That 1 unit can be anything. Okay. Now, what I'm trying to do is this OMP, maybe if I can call it as O prime, M prime, P prime, this is a bigger copy of OMP, let's say. It's a similar triangle to OMP, suppose. I can do that. So these are similar. So this is 3 by 5 and this is 1. Now, can I, if it is similar, can I say that I can multiply OP with 5 and then OM with 5? I will get this triangle. Can I do that?
Yeah, sir.
Okay, so then I can say that this side is, if this side is proportional to 3, then this will be proportional to 5. Are you getting?
Yeah.
Then what do you think is this proportional to? If this is a right angle triangle, what do you think M prime, P prime will be proportional to? Can I,
MP, sir.
what is that all?
MP, it would be proportional to MP.
Yeah, it will be proportional to MP, but if this side, let's say this is 3, right? I have taken this as 3 units. So then how much will this be? If this is 3, this is 5, and then you have a right angle triangle, how much will this be? What can we use here? What theorem can we
4,
use?
sir. 4.
4, right? So how did you get 4?
Pythagoras theorem.
Very good. Okay, Pythagoras theorem. Okay, so this is 4. Now, I can, now you can backtrack, right? I mean, if I'm writing 3 by 5 as 3, 1 as 5. So that means when I go from 3 by 5 to 3, I'm multiplying by 3, right? When I'm going from 1 to 5, I'm multiplying by 5. Okay, so when I go from here, MP to M prime, P prime, I'm multiplying by 5. So can I claim that this MP will be 4 by 5?
Yes, sir. Yeah.
Okay, so MP will be 4 by 5. So that means my Y coordinate is 4 by 5.
Yes.
But almost. The magnitude is 4 by 5. But I can't take my Y coordinate as 4 by 5. I need to take it with a negative sign. You get this?
Yeah.
Okay, so with a negative sign, I need to take. So then I can say that here my sine x will be minus 4 by 5. Is that okay? My sine x will be minus 4 by 5.
Minus 4 by 5.
Minus 4 by 5. Okay. Now, this might sound too complicated, but I think this sort of understanding is important. Or else what you could have done is, instead of treating, let's say, like, instead of, I mean, sometimes it is actually a good idea to think in terms of this 3, 4, 5 triangle, because it is a common triangle that you use several times. At least if you talk to any a student who has done like 1 or 2 years of physics, he will tell you about this 3, 4, 5 triangle. It comes up many times. Okay, but if you don't want to do that, what you can do is you can just look at the triangle in the unit circle itself. Okay, now OP is 1, OM is 3 by 5. I can just use the Pythagoras theorem here, right? So if I use the Pythagoras theorem here, OP square is OM square plus MP square. I can just use it here. So when I do that, OP square is 1, OM square is 3 by 4 square plus MP square. Now let's solve this, okay? So 1 equal to, so 3 by 5 whole square is 9 by 25 plus MP square. Now MP square comes out to be 1 minus 9 by 25. So if you look at that, that is 16 by 25. Now MP square is 16 by 25. So that gives us MP as plus or minus 4 by 5. So now I have two values. Okay, I mean, if I use Pythagoras theorem, the value of MP can be 4 by 5 or minus 4 by 5. But which one will I select? That is decided by the information that is given here. Okay, so X lies in the fourth quadrant. I know in the fourth quadrant, the sign value, okay, which is given by the Y coordinate is negative. So hence I will select minus 4 by 5. Okay, I think that makes sense.
Yeah, sir.
Yeah. So then, yeah,
So, yeah, and instead of doing this, we could also just use sine square x plus cos square x is equal to 1. And since we already have cos x is 3 by 5, so cos square x is 9 by 25. So you get to the same conclusion.
Fantastic. Okay, so that is even better. Okay, so instead of using unit circle and all these similarity triangles, what Sudhanya is saying is perfect. I totally agree. Okay, because that kind of saves us a lot of time, because we are saying that we will use identities right here. So yeah, I did not use identities. That's very true. Okay, so if I just use sine square x plus cos square x as 1, then you will end up having sine square x will be 1 minus cos square x. So cos square x is 3 by 5. Now you are at the same spot, right? So it's like using Pythagoras theorem. Okay, so then this is unnecessary. Okay, now if it is unnecessary, why am I doing this? Okay, it is just to show you that we need to be careful about the sign of the trigonometric ratios. Okay, so if I just use the identity, it is fine. I'm not saying that it is wrong. In fact, it is suggested. Okay, it is suggested that you go with the identity. But once you get sine x value as plus or minus 4 by 5, if you have in your mind that, okay, my sine x has to be negative because they're talking about fourth quadrant, then you should always do only this, like Sudhanya did. Okay, are you guys following what Sudhanya is saying?
Yes, sir.
So this is better. It's just to show you that we are just going back to fundamentals. Okay. Okay. Now, once we have this sign value, how do we get the other values? How do we get the other values? Okay, so let me get another page. Okay, so now how do I get the other values? Okay, so now I have cos x, which is 3 by 5. I have sin x, which is minus 4 by 5. Now, the easiest thing is to get tan x right now. So tan x is sin x by cos x. Okay, so sin x by cos x. So then what do you have here? If you divide these two, you'll end up having minus 4 by 3. Then I can use the cos x. Okay, so if I use cos x, I can get secant x. Okay, so what is secant x? Secant x is 1 over cos x So I'm going to flip the ratio. Okay. So this will become 5 by 3. And then if I use sine x, okay, if I use sine x, I'll get cosecant x. So cosecant x is 1 over cos x. I'm going to flip this ratio. So that will be minus 5 by 3. And then if I flip tan, I'll get cotangent of x, cot x, so which is 1 over tan x, which is minus.
So minus 5 by 4, that one, cosecant x.
Oh, yeah. Thanks, beta. This is a mistake. Yes. So this is minus 5 by 4. Okay. Harsha, Om, are you okay? I think Sudhanya understands these things.
Yeah, sir.
Yes, sir.
Okay. Good. So, okay. Do you like the green board for solving problems?
Yeah, sir.
Okay. Because I don't know, I mean, I wanted to get that feeling of the chalkboard.
Okay.
I really like chalkboards. Yes. I mean, they have that scratchy feeling, but teaching is much better. Okay. Again, I'll wait here. So try to do this, yes. Okay. Now, if you recall, if you add 2 pi radians to the input, the trigonometric function will give you the same value, right? So suppose I have sine theta. Okay, I have sine theta, for example. Okay, so if I turn by an additional 2 pi radians, I'm going to get sine theta again. Okay, so here, if you look at tan 73 pi by 3, you could write this as tan of, let's say, I try to get a multiple of 3. So that is 72 pi plus pi over 3. Now this will be tan of 72 by 3, that is 24 pi plus pi by 3. Now 24 is a multiple of 2 pi. Okay, so 24 is a multiple of 2 pi. So now if you go around the circle an integer number of times, you're not going to change the trigonometric value. So can I say that this is as good as tan pi by 3? Because 24 is an integral multiple of 2 pi. So 24 pi, you can write it as 12 into 2 pi. It's like going around the circle 12 times and then coming back to the same angle, pi by 3. Okay, so this will give you tan pi by 3. Now, what is tan pi by 3? That is tan 60 degrees. So you should get root 3. Okay. So, okay, let me know if you have any questions here, or else we'll move forward. So, okay, I hope you're okay. So let's move on. Okay, so try this one. Okay, so this problem is a little like the previous one. In the previous one, we went, let's say, multiple times, okay, in the counterclockwise direction. So here you can go in the clockwise direction. Okay, so let's write this in terms of a multiple of 2 pi plus some other angle. So 17 by 3. Okay, so you can, let's say, try to get the near maximum, or let's say highest multiple of 3. That would be 15. Okay, so 15 pi plus 2 pi by 3. So we could write this as sine. What is this? This is minus 5 pi minus 2 pi by 3. Okay, now, but we don't have a multiple of 2 pi. So what can I do here? one thing that I can do here is I can just write this as, guys, can I say, I'll just make this minus 5 pi, minus 6 pi. Okay, and I'll make that minus 6 pi. Because I don't have minus 6, I have only minus 5. So I'll just add another pi. Okay, I think this is fine. Oh, sorry, that is 2 pi. This is 2 pi by 3. Okay, so this is okay, right? So I'm just taking this minus pi, I'm just splitting it. Now what do I have? I have sine of minus 2 pi plus pi minus pi by 3 will give me, sorry, pi minus 2 pi by 3 will give me pi by 3. Now what does it mean? Minus, what did I write? That is minus 6 pi, guess. Sorry, that is minus 6 pi. So what is minus 6 pi telling me? I'm going in the counterclockwise direction 3 times, right? So I'll come back to the same position. And then plus pi by 3, sorry, why am I saying counterclockwise? Guys, minus means what? Am I moving clockwise or counterclockwise? Correct me there.
Clockwise, sir.
Clock.
Clockwise.
Yes, I was wrong there. Okay, so I am moving in the clockwise direction. And then plus means I'm moving in the counterclockwise direction. So now if I move an integral number of 2 pi radians, be it clockwise or counterclockwise, I'm going to come back to my reference line, right? So that OX. Okay, so if it is helpful, I think we should imagine our unit circle here. Okay, so if you look at the unit circle, OX is my reference line. So if I am looking at minus 6 pi, so that means I'll go around the circle 3 times, right? I'll go around the circle 3 times, right? So 1 and then 2 and then 3. Okay, I'm just drawing it to help us understand it better. But you'll go back to the reference line. Okay, and after that, you're moving plus pi by 3. So that means basically this angle will take you to this position. Okay, so this angle will be pi by 3. Now it is as good as your sine pi by 3. Okay, now what is sine pi by 3? Is root 3 by 2. Okay, do we understand this? Okay, if you have questions, let me know, or else we'll move. Okay, so I'm hoping this is okay. Okay, so now try this one.
So I couldn't see it. And I have a doubt in.
Oh, okay. Okay, Nasha, yeah. Ask me your doubt.
So in the third step, here you said adding pi, right? So how would it minus 6 pi?
Okay, see. What do you have here? You have minus 5, right?
Yes, sir.
So minus 5, can I write it as minus 6 plus 1?
6 plus 1. Yes, sir, we can.
Yeah, so I'm trying to generate an integral multiple of 2 pi, because if I have an integral multiple of 2 pi, I know that it is going to bring me back to the original OX line, reference line. So I can just ignore that, right? So whenever I have an integral multiple of 2 pi, I can simply ignore. So that is why I'm converting this minus 5 pi to minus 6 pi plus pi. So now I'm taking these two together, and then I have minus 6 pi here.
Okay.
You understand?
Yeah, sir, got it.
And then minus 6 pi means, okay, because initially my advice is like go slow, always try to think about this unit circle until you like become really comfortable. Okay, so once you become comfortable, then I think you don't have to draw the unit circle always. It will be in your head. Okay, so minus 6 pi, because I can write minus 6 pi as 3 into minus 2 pi, it means I'm going in the clockwise direction 3 times. Okay, so that is what you should mentally think. So if I do that, I'll come back to the reference line. And after that, I am going plus pi by 3. So if you understand this, you know that you can always safely ignore any multiples of 2 pi. Okay, the positive multiples of 2 pi or the negative multiples of 2 pi. Okay, either of them you can ignore. Okay, because they don't change your output value. You understand, Harsha?
Yes, sir.
Then you are back to simply sine pi by 3, which is root 3 by 2.
Okay.
Okay, so try this one. I'll wait for a minute or two. Okay, so let us continue here. We can simply use this identity here. Okay, so we have sine of, guys, do you like sine of x minus y or sine of a minus b? Which version, I mean, you think you're comfortable? A minus b or
A
x?
minus B, A minus B.
You like a minus b. Okay, so we'll go with that. So sine of a minus b is sine a cos b minus cos a sine b. Okay. Now this 15 degrees I can convert. I mean, I can write it as 45 minus 30. Okay. So sine 15, I can write it as 45 degrees minus 30 degrees. So my A is 45 degrees. My B is 30 degrees. So then I can use this identity, sine of A minus B. So what will that give me? It will give me sine 45 degrees. Okay, cos B, which is cos 30 degrees, minus cos A, which is cos 45 degrees, and then sine B, which is sine 30 degrees. And now substitute these values. Okay, so sine 45 is 1 over root 2, and then cos 30 is root 3 over 2, minus cos 45 is 1 over root 2, and sine 30 is 1 over 2. So in the denominator, you see 2 root 2 common. So I think you can just put them together. Root 3 minus 1 by 2 root 2. Okay, so I'll pause here for a minute. Let me know if you have any questions. Okay, so I'm assuming there are no questions. Let us move on. Okay, now if you have understood the previous one, this should be easy. So you have a minute. Okay. Okay, so what can we do here? I think 15
30 plus 45.
30 plus 45. Very good. So instead of using sine A minus B, we can just go with sine A plus B.
Yeah.
So which is sine A
B, cos B
plus
cos A
and
sin B.
so sine 75 can be written as sine of
30 plus, yeah, sine.
we can do that. Yeah, we can do that. 30 plus 45. So your A becomes 30 degrees here. And then B is 45 degrees. So now sine 30 degrees multiplied by cos 45 degrees plus cos 30 degrees multiplied by sine 45 degrees. So sine 30 is half. Cos 45 1 over root 2, and then this is root 3 over 2 into 1 over root 2. So this time you'll have 1 plus root 3 or root 3 plus 1. I think either way is fine. So 2 root 2. Okay, so that is the answer. Okay, I think this should be easy. So I'll wait a few seconds. Okay, and we can move on. Okay. Okay, so try this one. Again, you have a minute or two. Okay. Oh, Yeah, say that again. No,
I think it would be 4 upon root 3, sir.
4 upon root 3. Okay. Okay, what did you do?
Tan 30 plus 45 degrees.
Okay, so we can do tan 30 plus tan 45. Okay, so let's verify this. Okay. So I can use, I think you use this tan A plus B,
Yes,
which is
sir. Tan A plus B.
tan A plus tan B, and then divided by,
1 minus tan 30 tan.
okay, so tan A into tan B. Yeah,
Yeah.
we'll substitute this. Maybe you are right, Om. Let's verify. So I have tan 30. Okay, so plus tan 45 divided by 1 minus tan 30 multiplied by tan 45. Now, what is tan 30?
Tan 30 is 1 by root 3.
1 by root 3. Very good. So tan 45?
1, sir.
1. Okay, so now I have 1 minus 1 by root 3 multiplied by 1, it will be just 1.
1.
Now here, I think if you simplify this, you'll get 1 plus root 3 by 1 minus root 3. Okay?
Yeah, that's what I
Okay.
got.
Now how do I verify and then confirm Ohm's answer? We can rationalize this, guys.
No, sir, I guess.
So the bottom one is root 3 minus 1, right?
We're getting, oh, yeah. She is right. See, I made a mistake again. So it cannot be 1 minus root 3. You
Yeah, sir.
understand?
Yeah, yes, sir.
Thanks, Sudhanya. Yes. This is not 1 minus root 3. That is my mistake. So this is root 3 minus 1.
Root
Yeah. Okay, so now can I rationalize the denominator? I think you guys are familiar with rationalization.
Yes, sir.
Okay, so what do? We multiply with what is it called? Sudhanya, what is it called? Is it called conjugate?
Yeah, I guess so. I don't remember the terminology
Okay.
properly.
I think we just multiply by root 3. I think root 3 plus 1
Plus 1. Yeah, we just change the sign.
We just change the sign. Yes. So you're multiplying both numerator and denominator by root 3 plus 1. So we're not doing much. So in the numerator, you have what? Root 3 plus 1 whole square. And in the denominator, you have a plus b into a minus b. So that would be a square minus b square. So 1 square. So now if I open it up, a square is root 3 square. So that is 3 plus b square 1 plus 2ab, that will be 2 root 3. Guys, just check. Divided by root 3 square will be 3 and then minus 1. Okay, so what do we have here? I think in the numerator you have what? 4 plus 2 root 3 divided by 4 plus 2 root 3 divided by 2. So this will become 2 plus root 3. Okay, are we okay? Om, do you agree with this?
Yes, sir.
Yeah. So just check your work arithmetic. Maybe I mean I did a mistake here, right? Maybe ऐसा कुछ हुआ होगा. Okay, so I should have taken here root 3 common. So it should be root 3 minus 1. By mistake, I wrote it as 1 minus root 3. Okay, yeah. I do such mistakes. Okay, so I'll pause here for a minute. Let me know if you have any questions, guys.
Sir, if we leave the answer like 1 plus root 3 by root 3 minus 1, would be okay or?
That's okay. That's okay. But see, if you are taking this as a test in your school, I think, let's say, I mean, if I'm in your teacher's position, I would expect you to bring it till 2 plus root 3. I mean, you rationalize and then simplify it. It's still correct. Root 3 plus 1 by root 3 minus 1 is correct. But I think as a teacher, I would expect you to simplify it and then give me 2 plus root 3. Sudhanya, what do you think? What is expected? I mean, you stop.
Actually to rationalize and give.
Yes. So you don't stop here. You rationalize and then
No.
right, Sudhanya?
Yeah. We just rationalize and give. It won't take so long. I mean, obviously this one's an easier one, so it's better if you rationalize.
Yes. Yes, I agree. Yeah. So it's better to rationalize. I mean, maybe like you could do it quickly because I'm showing you every step here. So maybe it took time, but I think it doesn't take much time, as Sudhanya pointed out. Okay, Harsha.
Yeah, sir.
Okay, so let us move on. Okay, so I'll wait for 2 or 3 minutes here. Okay, so let's discuss. I think sine pi by 6 and cos pi by 3, they're easy, right?
Yes, sir. They are easy.
So only troubling things are these.
Oh,
So
that one is also easy, sir.
this is also easy. Okay, so
Yeah.
only troubling this one.
Yes, sir. That one.
Okay, so let's check that first. Okay, so if you take tan of minus 3 pi by 4, okay, so minus is telling you that you are going in the clockwise direction. So
Yes,
how
sir.
much is pi by 4? Pi by 4 is 45 degrees, right?
Yes, sir. Pi by 4 is 45 degrees.
Okay, so 3 into 45 is 135 degrees.
Yes, sir. Yeah.
So if you mentally imagine your unit circle, okay, I'm drawing, but you can also imagine in your head. Okay, so if you look at this, so from the reference line, you're going clockwise, and then you reach this point. So this angle is 135, minus 135, or you can say this is minus 3 by 4, 3 pi by 4. So this
Yeah.
is basically pi by 4.
Yeah.
And let's say, what is tan pi by 4, tan 45 degrees?
Tan 45 degrees is 1, sir.
1, but because you are having an angle of minus 3 pi by 4, you are in which quadrant?
Third quadrant, sir.
Third quadrant. So third quadrant, your sine value will be positive or negative? Your y value will be negative or positive? This value.
Y value would be negative.
Negative. X value will be
X value would be negative.
negative. So sine by cos is your tan, right? So your tan will be negative or positive?
So it will be negative. Positive, sir.
Positive, right? And then how much is tan 45 degrees?
Tan 45 degrees is 1.
1. So this entire thing will just become 1. You're getting?
Then we are not supposed to use this tan A plus B by
You
1
can.
minus.
See, I'm not saying you can't, you can, but because if you closely look at all these, they're all familiar angles, right? I think if you take sine pi by 6, it's just half. And then this is 60 degrees. So this is also half. So these are all familiar angles. So you don't have to, right? And then you are saying the sine 17 pi by 4 is easy. How much is that?
It is sine 45, sir.
It is sine 45. I think, Om, you're okay with that? Sine 17 pi by 4.
Yes, sir.
Okay, so what you can do is, if you take 17 pi by 4, I can write that as 16 by 4. So that will be 4 pi plus pi by 4. So 4 pi is just a multiple of 2 pi. So that doesn't affect the sine output. So it is as good as sine pi by 4. So that means this quantity over here will be just sine pi by 4, which is 1 over root 2. And then I'm multiplying by root 2, and then there is a minus. Okay, so I'm multiplying. So here 8 by 4, so that is 2, minus root 2 by root 2, that will disappear. This is 1. So your answer should be 1.
So cos 60 is Never mind, sir. Yeah, it is 1 by 2.
It is half, right? Yeah.
Yeah, it's 1.
So then are you okay with this?
Yeah, sir.
Okay. Yeah. Okay, I think we can move on, right?
Yeah, sir.
Okay, so take a minute or two for this. Okay, so tan A minus
A
B
minus B. Yes, sir.
will be tan A minus tan B divided by 1 plus tan A into tan B. I'll write it here. Okay,
Okay, sir.
so tan of A minus B will be tan A minus tan B in the numerator
Okay.
divided by 1 plus tan A multiplied by tan B. Yeah. Okay, so try.
Yeah.
Okay, say that again, Harsha.
√3 minus 1 by √3 plus 1, sir.
Okay, so now if you rationalize it, and then what should you get?
Okay. Yeah, sir.
Yeah,
Yeah.
yeah. You can. I mean, it's for a complete solution. Okay.
Okay. Okay, sir.
Yeah. So. Okay, so 30 seconds and then we'll discuss. Okay, so here again, what you can do is you can just first write it as a multiple of 12, the numerator. So there is a 36, 37 can be written as 36 plus 1.
Yeah.
So you agree that you can actually write this as 36 by 12 will be how much? 3 pi?
Yes, sir. No, sir. 2 pi. 2 pi.
Oh,
Yes, sir. 3 pi. 3 pi. 3 pi. Sorry. 3 pi.
3 pi plus pi by 12.
Yeah.
Okay, so now
And 15.
so I think if you look at tan, can I say this is just tan pi by 12?
But
Hmm.
3 pi isn't like divisible of 2.
Okay, so what can we do? Now let us write it as maybe okay, but in your tan case, okay, so let's look at the circle. Okay, so tan case.
Okay.
You remember the graphs that I have shown, if you recall, the period of tan. You guys remember the period of tan?
Yeah, sir. Yeah.
No? Okay. Okay. So see, period of tan is pi radians. So every pi radians you repeat. Okay, so every pi radians you repeat. But okay, so if you don't want to use that, we can do it the way we were doing. Okay, so if I write it as a multiple of 2 pi, so that would be 4 pi minus pi
Yeah.
and then plus pi by 12. So this I can write it as tan of 4 pi minus maybe minus pi minus pi by 12, right? So
Yes, sir.
you can write it that way. And then what do you get here? You get tan of pi minus pi by 12.
Okay.
Okay. Now, do you think it is tan pi by 12?
Tan pi by 12. Yes, yeah, sir.
But will it be tan pi by 12 or it will be minus tan pi by 12? What do you think is appropriate?
Yeah.
Let's see. Okay, let's see. So if you take pi, pi is you're going clockwise or counterclockwise?
Pi.
Yeah, if you go pi from the reference line, you go clockwise, counterclockwise, right?
Yes, sir. Counterclockwise.
Okay, so now minus pi by 4 will take you where?
Minus pi by 4 will take you
Okay,
clockwise, sir.
clockwise. So that means you will reach some point here. Okay, so this is pi, and then this will be minus pi by 12, right?
Yeah.
So now I think we can safely say that pi by 12 is an acute angle. So you will lie in that second quadrant.
Yes,
Okay.
sir.
So if this angle is pi by 12, you will lie in the second quadrant. So
Yeah.
if you lie in the second quadrant, okay, if you lie in the second quadrant, your cos value is negative, sine value is positive, right?
Yes.
So
Yeah.
that means your tan value should come out to be negative. Agreed.
Yes, sir.
So if they come out to be negative, then can I write this as minus tan pi by 12? But I want you guys to think whether after this step, did I do it correctly? Did I do it correctly? Just think about it, guys. So
I guess it's like minus pi by 12. It's supposed to be positive pi by 12 because the negative is outside the bracket.
right. So here you are okay. So 3 pi, I can write it as 4 pi minus pi.
Yeah. Yes, sir. Okay.
Okay, so then I'm clubbing these two into a bracket.
Yes.
So there is a plus, so I need to make it minus, because if I go back, what will happen? If I distribute it, minus into pi is minus pi, minus into minus will be plus.
Plus.
You understand?
Yes, sir.
Okay, now for a moment, I want you to think like this. I want you to just say that whatever angle you have here, let's say this angle, let's pretend that this is some angle theta, let's say. Okay, so this is some angle theta. Now, when you go 4 pi, okay, so when you go 4 pi, what is happening? You're coming back to the same reference line. You understand?
Yeah.
So now, but after that, because of this minus sign, I'm actually moving in the clockwise direction.
Yeah.
Are you getting?
Yes, sir.
So now I don't know if this pi minus pi by 12 is actually, what do you think? Is it acute? Is it, what angle is that? It will definitely be
Cute, sir.
acute, or it will be more than 90 or less than 90, pi minus pi by 12. What do you guys think?
More than 90, sir.
More than 90, right? So that means you're going back to which quadrant? You're going to this third quadrant, right?
Yes, sir.
So in third quadrant, this will be positive. So tan will be positive. I think we are okay here. You guys understand this?
Okay.
Are you okay here so far?
Yeah.
Okay. Then how about this? Are we okay here?
Yes, sir. Yeah.
This minus is okay. Can I say you guys are okay so far?
Yeah.
Yeah, I know. These are challenging. Okay. Okay. I'll pause a minute here. So let me know if you are okay so far. Okay. So I'll give a breather for a minute. Okay. So when you say fourth step, from here to here, or from here to here?
Yes, I'm there too.
There, here to here, na? Okay.
Yes, sir.
So here, what I'm saying is, if you go pi,
Yeah.
that is counterclockwise, minus pi by 12, you're coming back here, right? This one.
Yes, sir.
So it's as good as taking as tan pi by 4, but because you're in the second quadrant, you will get negative values. Because roughly, if you take your pi is what 180 degrees, right?
180.
180.
Yes, sir.
So 180 by 12 is how much? 15 degrees?
180 by
15 degrees, no?
yes, sir. 15.
15 degrees, right? Right.
Yes.
So if you take your 15 degrees, tan 15 degrees will be positive. Okay, but that is provided you are in the first quadrant, 15 degrees. Okay, I think that's too much. Let's say 15 degrees will be even smaller. Okay, so you are in the first quadrant, but you are actually in the second quadrant, right? So that is why you should, you're taking, let's say you're going this and then back. Okay, so that is your tan pi minus pi by 12, or I think if you look at it, it is how much? 11 pi by 12, right? So pi, right? If you think in terms of degrees, okay, so pi minus pi by 12, this is 180 degrees, and this is 15 degrees. So you're looking at 165 degrees. So you're in this second quadrant, right? Harsha, you understand? Harsha, are you getting?
Yes, sir. Yeah.
Okay, so that means your value should be negative. If you just take tan 15, tan pi by 12, then you will go wrong. Okay. So,
Okay. Yeah, sir.
okay, so then you know how did we write tan 15 as tan 45 minus tan of 45 minus 30, right? Okay, I think I should pause here, guys. Okay. Oh, okay. Guys, I think we'll do one thing. Okay. Let's look at it from the beginning. Okay. Are we okay till here? Harsha, are you okay till here?
Yes, sir. I'm okay.
Harsha, are you there?
Yes, sir.
Yeah, you're okay till here, right? And then I think
Yeah,
this is
sir.
also okay.
Yeah.
Okay, now I think the most important step is this third step. Okay, so let's verify this, whether we have understood or did correctly or not. Okay, now this tan 4 pi, it just means you went around the circle twice, right? And then you have come
Yeah.
back to OX. So let's put that. Okay, so let's put that. Okay, so you went once, and then you went again, and then came back. So that means this is not really important for me. Okay, so I'll ignore that. Okay. Now, this minus is telling me that I'm going to move in the clockwise direction from my reference line, OX, right? Now, what is pi minus pi by 12? We've just got 165. So pi minus pi by 12 will give me what? So if I go in the clockwise direction, 165 degrees, it will push me into which quadrant? It will push me into third quadrant. Are you okay?
Yeah, sir.
Okay, in the third quadrant, is your tan value positive or negative?
Tan value is positive.
Tan value is positive, right? So finally, because it is positive, your final value should be positive. Can I say? When your final answer should be positive. Do you agree?
Yes. Yes.
Okay. So from here, we are just writing it as tan pi minus pi by 12. Is that agree?
Yes. Okay.
Okay. Now, tan 15. Okay, so this tan 15, how can we write? This is tan 15, right? So we will fix this, whether that minus sign should be there or not, we will just check. Okay, so first let us get tan 15. So tan 15 is how much? tan 45 minus 30.
Minus 30.
Okay, so that will be, if I use tan A minus tan B, just a minute, guys. Okay, so here, if I look at tan 15, I can say tan 45 minus 30. So tan 45, tan A minus tan B, I'm just writing because there's a little space here. So 1, tan 30 is 1 by root 3 by 1,
1 plus.
1 by root 3, right? So
Yes,
this
sir.
will give me root 3 minus 1 by root 3 plus 1. So if you
Yes.
rationalize this, I think we can quickly do the rationalization. You should end up having 2 minus root 3. Okay, now this itself is positive, right? Are you
Yep.
getting? This itself is positive. So now I am doubting my minus sign here. Are you guys getting? So these are things that you need to be careful. Okay, now can you suggest whether that minus is actually correct or wrong? Guys, think about it. Is that minus correct or wrong? Guys, what do you think?
Not.
Huh?
Not.
So because see, now let's look at it. Okay, so suppose if I look at 37 pi by 12. Okay, so 37 pi by 12. You can, let's say if I use the calculator. Okay, because this is something that we need to understand. Okay, so this, whether it is correct or not, will tell us whether we actually moved correctly from this step to this step. Okay, so from this step to this step. Now, let's say if I use the calculator, I mean, we are overdoing it at this stage, but let's say if I use a calculator. Okay, so 37 pi by 12 is what? 15 degrees. So 37 into 15 degrees. So how much is this? 37 into 15 will be 5. Okay, so now if I use a calculator, tan of, I don't know whether I have set it to degrees. Let me check. This is another thing. Okay, so let me, 1 second, guys. Yeah, I think I have it in degrees only. So tan 55, sorry, 5. Okay, so I'm getting a positive value, which is 0.267. I think that is okay, right? So 2 minus root 3. Okay, root 3 is how much? 1.732. So you're getting a positive value. Okay, so this is roughly 0.267. But now, like I was saying, then this minus is wrong. I mean, my calculator is telling me that I should get a positive value. So where did we go wrong? Okay, can you spot where we went wrong? Guys, are you with me?
Yes, sir. Yeah.
So where did we go wrong? See, now here, if you look at 4 pi, so 4 pi is what I'm going around the circle twice, right?
Yeah.
And then this minus pi minus pi by 12. Okay, so which is 165 degrees. So that means I will go back to minus 165 is taking me to the third quadrant. Okay, so when I go to third quadrant, in third quadrant, my values are positive. You guys understand?
Yeah, sir.
My values are positive. Okay. Now, but if I use this pi minus pi by 12, okay, pi minus pi by 12, I will not go to third quadrant. Okay, so if I start with pi minus pi by 12, I mean, let's say this entire thing should push me to third quadrant. That is what we should get. But if I use this, if I use pi minus pi by 12, I will not go to third quadrant. Okay, so what mistake we have done is, we should take this minus sign there. You understand? So tan of a multiple of 2 pi plus theta is tan theta. You guys understand? So tan of a multiple of 2 pi plus theta. Okay, so not minus theta, plus theta. Okay, so you are going to take this entire thing as an angle. Okay, so I should actually take a minus sign. So that minus sign, maybe I can put it up front. Okay, so when I do that, okay, so a minus sign here, then this minus into minus will become plus. This will become plus. This will become plus, and then we are okay. Are we with me here?
Yeah, sir.
You guys understand?
Yeah. Yes, sir. Yes.
Okay. Now, another thing, like once you get these degrees, na 5, 5, 5, 5, 5, let's say close multiple of 180. Suppose close multiple of 180 will be how much? 540, right? 540 degrees plus 15 degrees. Now, how much is 540? It's like 3 into 180 degrees plus 15. Now think about it. Okay, so if you're going 3 times 180, let's say you start from here, 180 plus 180 plus 180, right? You are on the negative x axis. Then another 15. So you should go to a third quadrant. Okay, go to a third quadrant. So from here, this minus should be carried forward. Okay, so I did not carry that forward. So that is why I went to second quadrant instead of going into third quadrant. So that is where this minus sign is important. Are we okay here?
That's
Yeah, I think, see, so initially I should advise you to take it slow, make sure which quadrant the angle really lies, okay, approximately, or if you can get, in this case, I think you can actually get in which quadrant the angle is lying. Okay, so I think, what do you think? We should take a break?
yeah, sir.